Curiosity explores some giant mesas, finds a Martian meteorite, and captures multiple dust devils. Curiosity is closing in on the Murray Butte site, informally named after planetary scientist Bruce Murray, who was a former director of NASA's Jet Propulsion Lab in Pasadena, California. The two most prominent mesas in this image are about 260 feet or 80 meters apart. The mesas are about 33 feet or 10 meters high. The buttes and mesas here are thought to be eroded remnants of ancient sandstone, created by wind-blown sand, after lava Mount Sharp had formed. They are capped with material that is relatively resistant to erosion, giving them a top-heavy appearance, as is the case with many buttes and mesas here on Earth. The rover gets a view from a different position. The relatively flat foreground is part of what scientists are calling the Murray Formation, which includes ancient lakebed mud deposits. We've seen this formation in previous episodes and examined how it interacts with the Stimson unit, made up of darker layered deposits. Curiosity moves closer to one of the buttes, which is given the affectionate nickname Butte M9A. It stands at about 16 feet or 5 meters above Curiosity. On the left side of the butte, the average slope is estimated to be at about 40 degrees, while the right side is less steep at about 30 degrees. The rover takes a step back to get yet another view of this scenic area. It will now pass through the buttes. The rover takes 5 incredible close-up images on its way through. The thin layers here are evidence that this area was created by wind action, and sand dunes this is known as cross-bedding. The angles of some of the layers also give this indication, as water-based deposits tend to be more level. Now almost safely through the buttes, Curiosity takes a drill sample and celebrates by, you guessed it, taking another selfie. On Sol 1505, Curiosity comes across a very strange rock. Using its laser, the rover confirms the rock to be an iron nickel meteorite, the shiny white spots you can see on the rock are due to the laser pulses, and the meteorite is around the size of a golf ball. Curiosity looks toward the higher elevations of Mount Sharp. These annotations give a sense of distance and scale. On Sol 1555, the rover stumbles upon a portion of the Murray Mudstone Formation, which shows what could possibly be ancient, fossilized mud. This small grid of polygons could have originated as cracks in drying mud over 3 billion years ago. The area is given the nickname Squid Cove. The polygons are around 1 to 2 centimeters, or half an inch to an inch long. Another rock slab in the area showing the same type of pattern is observed. It's given the nickname Old Soaker. Curiosity drives to get a closer look. This pattern would have been created by a 3-step process after ancient Martian mud dried out, causing it to crack first. Wind-blown sediments filled the cracks. Second, the sediments and mud became rock, under the pressure of younger layers, accumulating above them lastly. After the younger layers were removed by the wind, the sedimentary areas remained, being more resistant to erosion than the mud, causing them to appear as ridges now, instead of the cracks they originated as. On Sol 1587, Curiosity takes a break from driving. The team picks up the next day where they left off, and sees that the sand beneath the rover has moved. This constant action from the wind is responsible for a lot of the rock formations and dunes we've seen so far. The area pictured beneath the rover is around 3 feet or 1 meter across. It's summertime in Gale Crater, and Curiosity spends the next few days Observing dust devils. These dust devils are created by the sun heating up the surface, causing convection currents as hot air rises, carrying dust with it. They are most active in the Martian summer as they are here on Earth. In this recording, we can see the dust devil disappear over a hill in the distance. In reality, the dust devils are moving much slower, as the images making up this sequence were taken in intervals of 12 seconds. On Sol 1598, Curiosity reaches a strange-looking hill. It's given the nickname Ison Hill and stands about 16 feet or 5 meters high. Nearby is a large dune field. It's given the informal name Nathan Bridges Dune, in memory of the planetary scientist Nathan Bridges, who was leading the Curiosity team's Dune campaign. On Sol 1641, a wheel check shows a break in the raised tread on one of Curiosity's wheels. These raised treads are called grousers, and testing with identical wheels on Earth shows that when 3 grousers are broken in any one wheel, the wheel has reached around 60% of its useful lifespan. Fortunately, the slow rate at which the grouser's condition is deteriorating means Curiosity can continue for quite some time. Other images taken during the wheel check show a slight increase in the number and the size of holes present. On Sol 1647, the team spots part of an active sand dune that contains features not seen back here on Earth. The dark crested ripples are several feet apart, and this particular mix of medium-scale ripples, along with the smaller scale ripples, are, as far as we know, unique to Mars. The area is given the nickname Algonquin Beach. Curiosity's planned route will take it over a large ridge, known as Vera Rubin Ridge. The mineral hematite had been identified on this ridge by the Mars Reconnaissance Orbiter well before Curiosity's landing, and it has always remained a target of interest. The rover is now approaching the ridge. As Curiosity gets closer, the laid deposits making up the ridge become clearer. The rover will now begin to climb up the ridge. As this map drawn up on Sol 1750 shows, the Vera Rubin Ridge climb will give Curiosity access to special areas higher up Mount Sharp, such as the clay and sulfate units. The yellow line beyond Vera Rubin Ridge shows the proposed route. As the 5th year of Curiosity's mission draws to a close, the rover is watching out for Martian clouds. The 8 images in this sequence were taken over a span of 4 minutes. The clouds are similar to cirrus clouds on Earth, likely composed of crystals of water ice, which condense onto dust particles in the thin Martian atmosphere.